class. Yes, it's almost a first class, Mohammed. In the last class, we just had the introduction part as well as we have discussed some basic stuff like types of communication, modes of communication, as well as types of networks. So technically, it's a second class. So if you enroll for this course, you will be getting the recording of the last session as well. Okay, you'll be getting the recorded session. All right. So types of addressing. As we were having this discussion that in a network, we always have the endpoints, guys, the devices which are going to utilize the network. Let's say you might have a desktop, you have a laptop, right? A mobile phone, a tab, printer, server, CCTV cameras, biometric machine, and a lot of other devices we can have in a network. Can we get a browser like what we gonna learn in this entire CCNA course, a PDF kind of thing? Yes, guys, you'll be getting it. Once we'll create the WhatsApp group over there, it will be shared. Okay. I hope it is already shared with you guys. But if it's not shared, then once we'll have the WhatsApp group, we'll be sharing over there. Okay. So all these endpoints, desktop, laptop, mobile phone, printer, tab, what they need in a network. First of all, they need a centralized device and which is known as a switch. We'll be having this discussion. How does this a switch looks like, how to make the configurations and all. But all of these endpoints are connected to this switch so that they can communicate with each other. So that they can communicate with the each other. You can have a mobile phone. So mobile phone is connected through Wi-Fi router. So this is the Wi-Fi router. There's a wireless connection, but the Wi-Fi router is also connected to the switch. This is what we have a printer here, and all these devices are connected. So once they wants to communicate with each other, they must be having a unique identity. Similar to us, right? As a human being, we also have a name. Why does that name is required? To have an identity, right? So that we can also communicate with other people. We can have a conversation. We can have an identity. Likewise, the devices are also having types of addressing. So here we have two types of addressing mainly. The first type of addressing is known as the physical addressing, and the second addressing we have is the logical addressing. So in the physical addressing, we have MAC, Media Access Control Address. If you guys know anything about MAC, please say yes or no in the chat box if you are aware of it. If you're not aware of it, no problem. We are going to start from scratch. Media Access Control Address. If you have an idea of MAC, great. Otherwise, no problem. In the logical addressing, we have IP address, Internet Protocol, or you can say IP address. So we have these two type of identities, the physical address and the logical address, Internet Protocol address. So guys, whenever you connect to the network, whenever a machine connects to the network, it always need a physical adapter. It always need a physical adapter. If you look at LAN ports on laptop. Let's say if you have a laptop, you might have noticed that your laptop is having a LAN port like this or like this, in which you plug in a cable. Nowadays, this RJ45 interface is not available in the laptop because laptops are very thin. So they have a USB port or Type C port. So you always need a LAN to USB converter. You always need a LAN to USB converter. So whenever any endpoint connect to the network, it always have two types of connectivity options, either wired or wireless, either wired or the wireless. So this hardware or this part is known as the network interface card. Network interface card. And for wireless connectivity, we have the antennas, or you can say the network interface card, but that's not visible. In most of the devices, the wireless adapter or the wireless network interface card is invisible because it's inbuilt. So all of these machines or all of these physical components are having a hard coded address, which is worldwide unique. And that address is known as MAC address, guys, media access control. So if I show you, the MAC address belongs to the device, but as well as it is hard coded on the network interface card. Let's say, for example, we have a network interface card inside a machine. So you notice that on this machine, we have an identity, MAC. You see something like this 0026 B65 FE09E. So this is the identity of the machine. Either you are using a Wi-Fi adapter or you are using the LAN adapter. Your machine is always going to have a physical address, guys, and that address is known as MAC, media access control. But the machines are also having a logical addressing because the problem with the physical addressing is it's media dependent, but media can change. Like if you talk about you have ordered something from US, let's say you are importing a jacket. So you notice that this is the message or this is the content, but the way of transportation is going to change. It might be going in a truck to the airport. Then by flight, it will come to the airport in India. Then again a truck. Then might be a motorcycle. And then the message will be delivered to you, or then this jacket will be delivered to you. So you see that in between the media is or the transport is changing. Likewise, the media can also change when the traffic is going from source to destination. From source to destination. That's why a logical addressing is also required, and that logical address is known as IP address. How you can check it on your machine? Because you are not going to open your laptop using a screwdriver, right? Okay, let me get the network interface card. I want to see the MAC address. No, you just want to see the MAC address using this graphical user interface. So either you can go to the GUI or you can type it in the CMD. So in the CMD, you can type ipconfig backslash all, ipconfig backslash all. Right now, this is my Wi-Fi adapter. My LAN adapter is not connected because I'm not having a LAN connectivity here. Only the Wi-Fi adapter is connected. So on the Wi-Fi adapter, you can notice that we have both the addresses or the identities. One is the physical address, but it's known as MAC address. And the second, we have the IP address, which is 172.20.10.4. And this is known as the MAC, media access control. So who assigned these addresses, guys? Who is going to assign these addresses, or who are going to give these identities? Mhm. So MAC address is by default there. A MAC address is already assigned to a machine. A MAC address is already assigned to a machine, but the IP addresses are assigned by the network engineers. It depends what type of IP address is this, but the IP addresses are assigned by the network admins. So first of all, let's talk about the MAC address. Then we'll discuss about the IP address. Why does it look like this? What is this format known as? And all. But before that, let's talk about number formats here. So guys, in CCNA or in this particular section, we are going to face three type of number formats. First is binary. How many values do we have in binary, guys? Tell me in the chat box. If you have a binary number format, how many values we have in binary? Yes. So in binary, we have only two values, 0 and 1. Then we have hexadecimal, or you can say decimal. So in decimal, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in decimal, we have 0 to 9. So if you see a number like this, 1101, or let's say you have 200. So 200 is a decimal number. Then we have hexadecimal. So in hexadecimal, we have again 0 to 9. Then you have A, B, C, D, E, F. That's why we call it hexadecimal. Hex means 6. So we already have the decimal numbers 0 to 9, but we have added 6 characters here, A, B, C, D, E, F. So this is known as hexadecimal. So if you look at the MAC address, guys, what do you think? The MAC address is represented in which format? Binary format, decimal format, or hexadecimal format? Hexadecimal. You want to guess for IPv4? IPv4 is represented in decimal format. That's a decimal format. If you see 172 number, so in 172, what do we have? We have 1, which is a decimal number. 7 is also a decimal number. 2 is also a decimal number. So it's a decimal number, guys, 172. So these MAC addresses and IP addresses are represented in decimal and hexadecimal. But for a machine, it's always in binary format. That's a different story. We'll discuss about it. But first of all, let's discuss about the basic properties of a MAC address. Basic properties of a MAC address. So as its name suggests, media access control. Media access control. Hard coded, physical or hard coded. Assigned by the manufacturer. Length of MAC address is 48 bits, guys. Represented in hexadecimal format. Worldwide unique identity. You need to replace the hardware in order to change the MAC address. If you want to change the MAC address of a device, You can't change it directly. You have to replace the hardware. But you can change an IP address. If you want to change the IP address, you can simply change it. You can just go to the configuration and you can change the IP address of a device, but you can't change the MAC address. If you want to manipulate it or change it, you have to change the hardware. A hex value contains 4 bits and MAC address has total 12 hex values. So if you look at the MAC address, I said MAC address is 48 bits, but if you look at this, you see only 12 characters: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the length of the MAC address is 48 bits, but if you represent it in hexadecimal value, you can only have 12 hex values. You're only going to have 12 hex values. And it's already assigned, guys. It's already assigned to a device. Now let's go towards the number formats. Don't get confused. It's very easy. You just have to pay attention and be patient. Okay, you guys have to revise the classes. Here you will understand the process, but if you're not going to revise the classes, it's not going to be easy for you guys. Okay, I'm just, I want to be honest with you, because for at this moment you will see, okay, understood, understood, understood. You'll say, okay, we already understood this thing, we don't need to revise it. So if you'll be having that mindset and you'll not revise the classes, then after 2, 3, 4, 5 days, you'll be on the starting page again. So that's why revision is very important. But can you stop watermark feature? My email and phone number is moving around the screen. But we don't see your this number and all. You have to fix it on your side, Sridhar. We don't see anything on our screen. Watermark feature. Yeah, the screen is being recorded. I have no idea about this problem. Can you? I think it's by default we are getting off for everyone, because if someone, can you share the screenshot here in the chat box? Please share a screenshot in the chat box, guys. I don't see what's the problem here. Hello, Josh. Yes, just a second, guys. Let me allow you to unmute. Yes, please tell me. We haven't faced any such problem in earlier classes. Hello.
Can you check with others also facing the same issue? Because my phone number and email IDs keep on moving all corners of the screen. It's disturbing me actually.
I'm also facing same problem, sir. My number and email IDs both are revolving. Both are moving.
Yes, I think it's for everyone.
But how to solve it? Because that's the first time I got this query.
As per my understanding, why it was coming right, if someone was recording the session and sharing it to someone else, right? So they can able to get that person who recorded the session. Like, yeah.
Okay, just a second then. But I don't see this watermark related settings even in the portal else portal also. Settings meeting.
आई थिंक सर आप जो है पोर्टल के थ्रू लॉगिन है ना, हम पोर्टल के थ्रू तो नहीं लॉगिन सब ना, हम तो डायरेक्टली वो आपकी वेबसाइट के थ्रू ओपन कर रहे हैं इसको, शायद मैं भी उस वजह से।
Just a minute, guys. Let me check. Watermark is already disabled.
Hello, teacher.
Yes.
Yeah, I'm about to leave the class because of work. I'd like to know if I can access the recorded class after.
Okay.
Will I access the recorded class?
Yeah, you can access the recording classes now.
Okay,
How is
thanks.
it now, guys? Is it fixed now?
The issue still.
Not
थोड़ी सी
No,
really.
sir.
Yeah, you can continue, sir. We'll see next class. I mean, you can check with your admin team.
Okay, guys. Okay, thank you.
Why to waste the time? Yeah.
So let me share my screen again. Yeah. I hope it's visible now. So as we were having this discussion related to the MAC address, which is assigned to a machine already on the hardware level, right? And it looks like this. This is the physical address or the MAC address represented in hexadecimal format. But for a machine, the MAC address or the IP address is always in binary format. Guys, having this knowledge is not going to make any difference, but still, if you have this understanding, then you will feel confident that okay, this is the MAC address, that's how it looks like, but that's not the machine understand. That's only for the human readable formats. So you can easily convert this MAC address to binary format as well. You just have to understand one thing. Like we said, MAC address is 48 bits. But if you look at this, you just see 12 values because each one is a hex and one hex is equal to 4 bits. So that's why 12 into 4, you have total 48 bits. So one hex values has 4 bits, and that's how you get 16 numbers. Because if you have 4 bits in binary, you can create 16 variables: 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1. and 100. Then you can say 1001, 1010, 1100, 1101, 1110, 1111. I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. One of the value is missing. 1011, 1100, 1101, 1110, and 111. So this is 0 here. This is 1, 2, 3, 4, 5, 6, 7, 8. This is 9, but this is not 10. This is going to be A, B, C, D, E, and F. If you want to memorize it, you can. Otherwise, if you want to understand it, that's also very easy, because guys, whenever you have a bit, one bit can have only two values, okay, 0, 1. Even you can convert your name to binary format. This is what machines understand. But all these things are designed for humans so that we can understand it better. We can work with it. Otherwise, in binary format, it's going to be look like a very big number. Like this is the MAC address in hexadecimal, but actual format is in binary always, the 48 bits. So if you convert it to binary format, you will see that this is going to be the binary format for this MAC address. If you have C, what do you think? What is the binary for C? As mentioned here, right? So for the C, the binary is 1100. Again, guys, you don't have to remember this. If you want to understand, great. Otherwise, we don't have to convert it to binary format. But always remember, this hexadecimal format is just for human readable format. Actual format is always in binary. So after this, we have 4. So 0100, 7, 0111, 5, 0101, A, 1010, B, 1011, 5, 0101. Then again you have 0. So 1, 2, 3, 4, 5, 0101, 3, 0011, 4, 0100, and then last you have 8. So 1000. Hmm. 4. Okay, after this 4, we have the 8, 1. Hmm. So that's how the MAC address looks like. This is the hexadecimal format and this is the binary format. So that's why we always represent it in hexadecimal, guys. It's easy to understand. Now, how this MAC address is distributed? Who assign these MAC addresses? Because we always have this MAC address on the physical adapter or physical media. Even if you have a smartwatch, earbuds you're using, all they have a MAC address. So this MAC address is having 48 bits. But how it is controlled? It is controlled using a very simple technique here. There's an organization known as IEEE. So this IEEE organization control this MAC addresses. And they said that in a MAC address, you have how many bits in total? You have 48 bits. So you have first 24 bits and last 24 bits. The first 24 bits are controlled by IEEE. Defined by IEEE. And the last 24 bits are vendor defined. Who is the vendor? If I have the MAC address on my adapter, I can simply go to Chrome and I can say MAC vendor lookup. Yes, vendor means the manufacturer, or you can say this. So this MAC address is given by Intel Corporate. It means that this Wi-Fi adapter is from Intel. Likewise, I have an Ethernet adapter, which is not connected right now because we don't have Ethernet cable. This is the MAC address on Ethernet adapter. So if I put it in this MAC vendor lookup, you will see that this is the vendor for the physical LAN adapter. So IEEE do what, guys? IEEE control the first 24 bits, and this is known as OUI. Organizationally unique identifier. Organizationally unique identifier, the first 24 bits. So vendor will always go to IEEE that we want to create LAN cards. So vendor A and vendor B, let's say. So IEEE will be giving the MAC addresses. So IEEE will say, okay, 0010 AB 000000. So this is the first 24 bits, guys. This is hexadecimal format. Vendor 2 0010 AA 000000. So last 24 bits given to the vendor. You can do whatever you want to do. You can create variables, but first 24 bits will remain fixed. That's how they make sure that the MAC address is worldwide unique. That's how they make sure that the MAC address is worldwide unique. So first 24 bits are defined by IEEE. Make sense till now? Any challenge here? Please feel free to ask. Okay. Let me show here, guys. This is a simulation tool. We will be using it throughout our CCNA training. But at this moment, please don't focus on the packet tracer. Just focus on this lab. Okay. I just want to show you a basic practical here. Later on, I'll explain how to install the packet tracer, how to connect these devices, what are these cables and everything. But right now, you see, once we connect all these users here, what they do have, if you click on this PC, you go to the config section, interface, you will notice that the device is having a MAC address. The device is having a MAC address. The MAC address is already there. I haven't configured any MAC addresses and all. If I go to the second desktop, config, interface, there's also a MAC address. This is the MAC address of this device. We go to the third PC, config, interface. This is the MAC address. Likewise, if we go to the fourth desktop, config, interface, and this is the MAC, which is already assigned. We haven't configured. Can two devices have same MAC address? No, it's not possible, Pooja. Then it will be a conflicting address. For switch also will have the MAC addresses. Yes, switch is also having a MAC address, and that MAC address is known as base MAC address. Okay. But two endpoints are not supposed to have the same MAC address. That's why IEEE control this. IEEE control the first 24 bits, and last 24 bits are controlled by the vendor. So we always try our best, make sure that two machines are not having identical MAC addresses. Two switches are, two users are not having identical MAC addresses. May I know what is management IP management MAC address means? At this moment, no. We'll discuss about it. Okay. Right now we are having the discussion related to the MAC address only, not related to the IP. Okay. Now guys, if two user wants to have unicast communication, you guys remember unicast? What does unicast means? One to one. But how we decide this one to one? This is decided on the basis of addresses. Let's say if PC0 wants to communicate with PC1, so it will be using a source MAC address as well as the destination MAC address. So what will be the source MAC? 0007 ECAD 3D2B. This is going to be the source MAC address. What will be the destination MAC? 00D0 D3 5B 4D 6C. So this is going to be the destination MAC address. So basically the communication, either you are talking about unicast, multicast or broadcast, all these type of communication are based on the identities, guys. If source MAC belongs to one machine, destination machine MAC belongs to the another machine. It means that this is a unicast packet. What if I want to have broadcast communication, guys? What does broadcast means? What does broadcast means? No, not one to many.
One sender to all other.
One to all. Broadcast means one to all. Please mute. Okay, thank you. So now the question is, if PC0 wants to send traffic to everyone, what will be the destination MAC? Because source MAC is this, okay, 007 ECAD 3D2B. This is the source MAC because this PC is the sender. But what will be the destination MAC, guys? You can't use the destination MAC as this. You can't use this MAC address or you can't use this MAC address because they're the individual MAC addresses. That's why in MAC addresses we have a reserved address FFFF, FFFF, F. All F. This is known as the broadcast MAC address. Please pay attention here. How many bits do we have in the MAC address? In the MAC address, we have 48 bits, right? So the 48 bits and bits are in what? 0 and 1. Either they are 0 or they are 1. So if I just write down 48 bits here, 1, 2, 3, 4, 5, 6, 7, 8, 16, 32, 48. These are the 48 bits. You know how we convert MAC addresses, guys? We always convert the MAC addresses, the unique MAC addresses, by converting these bits using the variables 1, 1, 1, 0, 0, 1, 0, 1. So like this, we always do what? We just play with these bits and that's how we create unique numbers. I don't want to go this side, but this is very crucial to understand. that how does it works in binary in the background. So that's how it works. At one point of time, we will be reaching this point 1, 2, 3, 4, 5, 6, 7, 8. Then you have utilized all the possible variables, all the possible variables. This is the highest possible thing. You can't go beyond this. You have tried out all the variables and you reach at this point. You have reached at this point. You can't go beyond it. You can't go beyond it. So now if you break down it into 4 bits, 4 bits, 4 bits, 4 bits like this. So 1, 1, 1, 1. If we go back to the binary, what does 1, 1, 1 means? F. So that's how we got this MAC address. That's how we got this MAC address. This is the highest possible MAC address. You cannot go beyond this. You cannot go beyond this. So this is the binary, but if you convert it to hexadecimal again, so it is going to be F, F, F. So that's how we got this F, 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 guys. So always remember, we have just one broadcast MAC address, and that broadcast MAC address is all F. Broadcast MAC address is FFF, FFF, FFF. So if you want to deliver a message to everyone, all the machines, in that case, the destination MAC is going to be OLF. Makes sense, guys? Any challenge with this part? How we got this FFF? Please give me confirmation in the chat box so that we can proceed next. Okay. So that's how we got this broadcast MAC address. So if you want to deliver it to everyone, the destination MAC is going to be OLF. How I'll show you here. Let me show you in this packet tracer. Sridhar, is there possibility of having same Mac for two devices? Sridhar, we live on Earth, right? So we have the possibilities, but it's not the recommendation. Everything is possible, but each and every machine should be having a unique MAC addresses. That's why we use this approach. That's why we follow this approach. So we always try our best that two machines are not having same MAC addresses. But if there's some mistakes or any problem with the vendors, then we might be having same MAC addresses on two machines. Okay. Yes. So we wish that two machines are not having the same MAC addresses. They should always have a unique MAC. All right. Then let's come back to the discussion. We go to the packet tracer. Guys, right now, please don't focus on the IP address. I just want to show you the broadcast MAC. So I'll configure the IP addresses to these machines. We are not having this discussion at the moment. How does the IP works? Just look at the packet tracer 10.1.1.3 and 10.1.1.4. I'll show you here. Okay, we go to this PC, we go to the command line, and from this PC, I'll ping 10.1.1.2 reachable, 10.1.1.3 reachable, 10.1.1.4 we are getting a response. But in Packet Tracer, we have a very interesting feature, guys, known as simulation. So if you see right bottom side, on the right bottom side, we have the simulation. We go to the simulation, we go back to this PC, and I ping it again 10.1.1.2. So you notice this packet is delivered to only one machine and we got a response because it was a unicast packet. If I send a broadcast ping 10 dot, again like I said, don't focus on this, just focus on the Mac. If I open this header, you look at this data, guys, the destination Mac. You can look at this. The destination Mac is what? Okay, so this is the ffff.fff, and you will notice this time once this packet is delivered to the switch will give it to everyone and everyone will give a response. That's what we call broadcast. So I hope now you guys have seen it practically, that how does a broadcast looks like. Sent by one machine, delivered to everyone. Make sense? And
So
all
why there
these
is destination FFF?
that's what I've explained here. Why does the destination is FFFF? Because if you want to deliver this message to everyone, then source MAC is this 0007, right? But what will be the destination MAC? You can't use this MAC as a destination because this MAC only belongs to one machine. You can't use this MAC address as destination because this MAC belongs to this machine. And you can't also send this as a destination because this belongs to this machine. So we have to deliver a data to everyone. But what would be the destination MAC? That's what we have here, the broadcast. FFFF. That's why the destination MAC is FFFFF. Okay. You got your answer?
Yes, sir.
Okay. Any challenge, guys? Please feel free to ask. Okay. Okay, if this makes sense, great. For multicast communication. Okay, I was waiting for these questions. What if you want multicast communication? Then how we are going to get the MAC addresses? Will send to all devices within network? Yes, Sridhar, that's what broadcast means. One to all. So it will be sent to every other machine. It will be sent to every other machine. Okay. So guys, for multicast, we don't have any reserved MAC address. How to convert binary to hexa and max limit. You can unmute yourself, Pooja, and you can please clarify this, what you want to ask.
Hello.
Yes.
You just explained before that what is the maximum limit? That is for you divide in a 4FFF, and you said 12, right? Something you are
Yes.
converting. Yeah. Can you just explain once more to be more precise?
Okay, so you understand this part. This is a MAC address, right?
Mm-hmm.
This is in hexadecimal format. That makes sense, right?
Oh,
So now using this table, what we did, we have converted it to
yeah, you're
binary.
converting. Yeah.
When you convert it to binary, these things doesn't exist. Either you are using a colon or you're using a dash. This is just for us. For the machine, it's just
Oh,
continuous
okay.
48
Mm.
bits. For machine, it's continuous 8 bits. That's what I was explaining here. If we reach the maximum number or we reach the maximum limit, then the maximum is going to be 111. You can't make any further changes in binary, right?
Okay.
So now, once you want to represent it in hexadecimal again, so you'll do what? You'll divide it into 4 bits
For each, right?
because one hex value has 4 bits, right?
4 bits.
So then again, 11111 means what?
F.
F, right? So that's how we are going to get F,
F.
F, 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 F. But it doesn't look good, right? So you can just write it like this also for the simplicity.
Mm. You're just breaking it.
Yeah.
Yeah, perfect.
Make sense?
Yes, pretty much. Thank you.
Great. Okay. Now someone asked that what about multicast? Guys, I want your full attention here, okay? This is something going towards the binary side, but we have to understand actually, you know, I can take things just, over the top and just explain, go to the next topic, go to the next topic, but I just want you to build the knowledge. Otherwise, you can just read the books, right? So I just want to give you a good explanation here that how to identify a multicast MAC address and a unicast MAC address. So normally the MAC address look like this. If you want me to identify a broadcast MAC, I can just easily identify it without any doubt, because in the whole world there's only just one broadcast MAC address, which is FFFF, FFFF, then FFFF. But if you ask me to identify a unicast and multicast MAC address, then there's a you need some time to identify it. Why so? Because if you look at this MAC address, this is a unicast MAC, and the multicast MAC also looks similar. What you have to remember in this, you have to remember one thing. On a MAC address, this is known as the left side, okay, and this is known as the right side. So first of all, you have to convert it to binary from the left hand side. For C, the binary is 1100, and for 4, the binary is 0100. You don't need to convert the full MAC address, you just need to convert these two hex values. In this, the 8th bit, this is the 8th bit from left hand side. How many values you can have of a bit, guys? A bit can be have two values, either 0 or 1. Agree? either 0 or 1. So in this case, you have 8 bit, and this bit is known as IZ bit. We have a name for this, IZ bit. IZ stands for individual, and G stands for group. G stands for group. So if you look at this, IZ bit either can be 0 or IZ bit can be 1. You can have only two variables out of one bit. Either you can make it 0 or you can make it 1. So if this 8 bit is 0, then it is a unicast MAC address. And if this 8 bit is 1, then it is a multicast MAC address. You guys want me to repeat?
Yes,
Yes, sir.
one more time.
Okay. So this is a MAC address. From the left hand side, we will convert it to binary format. We'll convert it to binary format. You don't need to convert the complete MAC address. You just need to find the 8 bit. So 1, 2, 3, 4, 5, 6, 7, 8. The 8th bit is known as IZ bit. IZ means individual group. So guys, always remember, a bit can have only two positions. Either it can be 0 or it can be 1. If you have 2 bits, in 2 bits we have more options. The 2 bits can be 0, 0, 0, 1, 1, 0, 1, 1. But 1 bit have two possibilities. Now in this case, the IZ bit, which stands for individual group, this bit can be 0 or this bit can be 1. So if the value of this bit is 0, it means it's a unicast MAC address. So that's how the MAC address is. Are you freezed? No, I was not freezed. I was just giving you guys time to digest this. Okay. So make sense now? Okay. But guys, we don't have to be worried about this. The switches, the routers, they'll identify this. They will automatically identify this is a unicast MAC or this is a multicast MAC. Can we find why which MAC address is source and which one is receiver? Okay. Always remember this. Source is always unicast, guys. If you go back to the definition, unicast means what? One to one. Multicast, one to many. And broadcast is what? One to all. So if you look at this, source address is never going to define the type of communication. Source is always unicast. Source is always one. The number of receivers are going to identify, or sorry, the number of receivers are going to differentiate the type of communication. If the number of receiver is just one, the communication is unicast. If multiple, then multicast. If broadcast, then it's a broadcast communication. Okay. All right, guys. What about in this scenario? You're checking it from right hand side. I said left hand side. Okay. A is on what side of the Mac? It's on the right hand side. We have to convert it from the left hand side and then we have to see. Okay, Mani Kantha? Yes. See, I have converted C and 4. I haven't converted 4 and 8. Where we can use this multicast. So you will use multicast, Gopi Krishna, when you want the multicast communication. If you want a message to be delivered to multiple machines, not to everyone. The multicast is also used by routing protocols like OSPF, EIGRP. They also use multicast. Okay. Yes. So that's all about multicast, guys. I hope, sorry, the MAC address. And it's always assigned to a machine. The next address which we're going to discuss is IP. But what is this check mark I see on my screen? Green sign. I don't see what is this, guys. There's all these check marks on the screen. Don't have these problems in earlier sessions. Given my number and mail to. I'll talk to the admin tomorrow. Then we'll see. Okay. The next thing is IP address, guys. I'm sure in might be in college you guys have heard of this IP address. By the way, if I tell you a fact, let's say if we go to the Google and we say total number of internet users in India. So right now it's saying that India has over 1 billion internet subscribers. So if we have 1 billion internet subscriber, what do you think? How many of them are aware of IP, guys? How many of them know that, okay, this such thing exists as IP and all? The percentage is going to be, I think, I'm not sure 1%, 0.1% might be. Because, if you are from IT background, technical background, or you have done your CCNA, CCNP, then you know about the IP addresses. But just think about every internet users. They're not aware of these things, IP, MAC. Why? Because the things are, or the technology is very user friendly. So whenever companies build any product, they always focus on the end user. The thing about the end user. Are we going to make it more technical or more simplified? So that's why you see billions of people are using the internet, but only few of them know about IP addresses. But now the question is, does internet works without IP? No, not at all. Internet cannot works without an IP address. So that's why IP address is very important. And for us network engineers, very important to understand how does this IP address behave. So in IP, we have two versions, guys, IPv4 and IPv6. IPv4 and IPv6. But first of all, our focus will be on IPv4. First, our focus is on IPv4. Internet Protocol version 4, IPv4. 32 bits long address represented in dotted decimal format. By default, a machine does not have an IP address. IP address can be assigned manually or dynamically. So most of the time when we use the internet, the IP address is assigned to a device automatically. We have zero contribution in that. And there's a protocol behind it known as DHCP. So IP address can be assigned manually or dynamically. IPv4 is divided into 4 octets, and each octet contains 8 bits. A dot is used to divide the octets. That's why we call it dotted decimal format. So if you look at this, if you look at the IPv4 address, that's how it looks like. So this is not a hexadecimal format, guys. This is a dotted decimal format. But again, like I said, for a machine, either it is a MAC address or it is an IP address, they are just continuous bits. But for our own understanding or for the simplicity, we have these formats. So in this, you have 4 octets. The first octet, second octet, third octet, and fourth octet. So in this IPv4 address, we have total 4 octets. First, second, third, and fourth. First, second, third, and fourth octet. And this IP address is divided into 4 octet, and we are using what? We are using a dot here to differentiate, or you can say to divide the octets. Now, one octet can have 8 bits. That's why this IP address looks like this, but again, it is also a continuous 32 bits, guys. Right now, we haven't seen the format, the binary format, but again, if you look at IP, this IP address is also going to have 32 bits. Like IPv4, sorry, MAC address has 48. So 1, 2, 3, 4, 5, 6, 7, 8. 16, 32. Again, in continuous bits, 0, 0, 0, 0, 0, 1, like this. But for the simplicity, we represent the IP address in dotted decimal format. So again, in this IPv4 also we have total. What is octet means? Octet means nothing. 1 octet is equal to 8 bits. So this is just a unit, okay? One octet means 8 bits. So we have divided into 4 parts. 1, 2, 3, 4, 5, 6, 7, 8. 8 bits. 4, 5, 6, 7, 8. 8 bits. 1, 4, 4, 8. And 4, 8. So 1 octet has 8 bits. That's why we call it octet. Okay, Pooja? But what is the difference measure between IP and MAC? IP is not assigned to a machine by default. You can assign it either statically or dynamically. If I show you on my PC, if we go to the adapters, these are the LAN adapters. So Ethernet is not connected, but Wi-Fi is up and running. If you right click here, you can go to the properties. In the properties, you see that we have two options. IPv4 option is there as well as IPv6. But right now we are having the discussion related to IPv4. If we go to IPv4, click on IPv4, click on properties, you notice that you have two options. Obtain an IP address automatically and use the following IP address. So if you click on this, you have to mention the IP here. And if you click on obtain an IP address automatically, then it will get an IP with the help of a protocol known as DHCP. We'll be having that discussion, but at this moment, just understand this thing. IP address can be assigned manually or dynamically. IPv4 is divided into 4 octets, and each octet contains 8 bits. Then a dot is used to divide the octets. I hope till now it makes sense. And this IP address is not media dependent, guys. Either you have Ethernet media, fiber optical media, any type of cable, or the wireless media, the device is always going to have a IP address. Let's discuss the last thing for today, and then we'll be continuing tomorrow because it's very new things for you guys. Straight 2 hours is going to be very difficult. So this is the, what is the virtual IP? In what context? Sir, what is, again, you guys are asking the same question similar to the Mac. Can we assign same IP for two pieces? Yes, you can assign same IP for two pieces. But again, if you look at this IP or MAC, what are these? They're identities. So if you'll give same identities to two different machines, they're always going to have a conflict. So if it is by mistake, understood. But if you're doing it intentionally, if you're configuring same IP addresses on two machines intentionally, guys, then you're going to face a problem. So please make sure each machine is having a unique IP and unique MAC address. What if we send a packet to the same IP PC, to which PC it will go? Okay, let's go to the packet tracer. This device is having an IP address, right? 10.1.1.1. So let's go to the PC command prompt. Ping 10.1.1.1. It's getting a response from its own adapter. The packet will not go anywhere else. Even if we go to the simulation mode, the packet is not sent. The packet is processed by the device itself, right? So if you'll ping the IP address, let's say your name is Manikanta. So if you say Manikanta, so he's going to give the response. You are going to give the response. Okay. Make sense? I mean, for PC0, PC will assign the 10.0.0.1. From PC2, 10.0.0.2 will send a packet. You can unmute yourself. I didn't get your second question, Manikanta. What you want to ask? What is this? I mean, for PC0, I didn't get this.
Yeah, hi Amit. Actually, I had a doubt from earlier. For PC0, PC1, we will assign the 10.0.0.1. Okay, for PC2, we will assign the 10.0.0.2. Okay, from PC2, we are trying to send a packet for the 10.0.0.1. To which PC it will go? Either PC0 or else PC1 it will.
So first of all, if you're going to assign the same IP here, sorry, if you go to the real time, we change the IP here 10.1.1.1 and subnet mask. So you see that the address is already used in the network.
Oh, okay. Can I tell you one scenario? Like we will remove these connections for the PC2 switch, and then we will assign the
Yeah,
IP
by
address.
default,
Then
it
we will
generates
send the
the
connection.
Gracious ARP, and with the help of the Gracious ARP, it will detect it. Let's do this. Now both the machines have the same IP address, this machine and this machine.
Yes.
We go to the simulation. From this PC, let's say I ping 10.1.1.1. So first of all, the machine will generate an ARP request. It's not sending an ARP request this time. I think it's already having the MAC. Just a second. It must be sending an ARP request. ARP A. Okay. Simulation mode. Ping 10.1.1.1. It will generate an ARP request. And the ARP request is broadcast. So see, the packet is going to the one host. Whoever gives the first ARP response, the packet will be forwarded to that machine. Okay. So there is no predictable behavior. That's just a random behavior here. So you can't commit anything where the packet will go. And you see that now the IP is not visible here. Even after that IP is removed, you got an error message that the IP is already assigned. Packet means request. Yes, packet means request. Can you please do a simulation in Packet Tracer for multicast? Multicast simulation is not possible here, Glady. Okay, multicast is a very vast technology, and to learn it, we have to go to CCNP actually. That how to deploy multicast. Because it's very difficult to identify a machine in multicast. Because you say one to many, but who are those many? How you are going to identify the many? Because if I say unicast, one sender, one receiver, broadcast, one to all, but then you say multicast, one to many. But the question is, who are those many? How we are going to identify those many, right? So that's why the deployment of multicast is a different thing. It's not our cup of tea right now in CCNA because, for that we have to learn a lot of things first. Only then we'll be able to deploy multicast. But yes, when we'll discuss about the routing protocols, I'll give you a basic idea of it. Internet protocol. All right. So then we'll do one thing with the IPv4. We'll be starting tomorrow. And in the next class, we'll discuss first how to convert an IP address to binary format, IP classes, why do we have different classes, then subnet mask, what is the role of the subnet mask. So there's a lot of things to discuss about IPv4 address, guys. So in the next class, we're going to start fresh with IPv4. Okay. I think that is enough for today. If you guys have any questions, please feel free to ask till now. Otherwise, we'll connect tomorrow, guys. Okay. If there's a WhatsApp group created for this batch, could you please add me to it? Also, can we remove the watermark on the screen? Believe it was distracting for everyone. Yes, I'll.
I think this is Zoom annotation tool someone is using on the stamp check. So that's why it's coming on their Zoom.
You're not receiving it, right, Pooja?
Right now, but hold the class, it was the mark, and it's like it's in Zoom. There is a annotation tool someone is using. I don't know. I see some name with the MOH and is flashing on the screen. I think that guy is using. If I don't pronounce the name MOH, yeah,
Mohammed?
his name is coming, and yeah, that's something tool that coming on the screen with the check marks. It's a
I'll also
check
inform
mark.
to the admin. I think he'll fix it.
Mhm.
Let's see.
Yeah, it's quite. I don't know who is using, but yeah, if someone is using, they can just drop down that tool or invisible. I don't know the how it works, but I think it's something check mark or annotation tool on Zoom itself.
Okay, we'll see. We'll try to fix it. And related to the WhatsApp group, right now there's no WhatsApp group because there are few people in this class who are on invitation, right? So if they'll enroll, then the team will be creating a WhatsApp group, guys. Only then the WhatsApp group will be activated. Once we'll finalize the candidate for this class or the students, after that we are going to create a WhatsApp group. Okay. The study notes will also be shared in that WhatsApp group. Yeah, sure. Sure. No worry about that. For the lab access, you can talk to the management, whoever the point of contact. Okay.
Hey, Ahmed, For any enrollment issues or login issues, we have to connect with the management guys, right?
For the lab, yes.
Okay. So because I just got enrolled yesterday and they tell me to create some of the accounts, but what I can see that you are not the right person to ask. So I'm not asking you those questions. I'm just confirming that this is something that they have to do by their own, not you, right?
Yeah.
Okay, thank you.
Hi, Amit. Like,
Yeah.
they said like the lab access will be told by you, like how to access it, like how to log in, how to create the credentials, like that. So they said like the trainer will say about that.
You guys got the lab, the credentials for the lab?
No, no, like I asked to my POC, just they said like you can ask your trainer. They said how to, they will say like how to access your lab, like that
They'll
they
tell
have
you that,
said
but
like how.
first the credentials are required. So once you receive the credentials, then let me know, okay?
So like I have enrolled already, like during from the first class onwards, like that's the reason like I was asking.
No, no, you'll need the lab credentials actually.
Okay, like just I will connect with the support team then.
Yeah.
Yeah, okay.
I think we are good to go, right?
Yes, yes, we are done for today.
Okay. Thank you for the lessons. I think we are leaving.
Yeah, yeah, right. Yes, Pooja. You can drop
Okay,
the
bye.
meeting. Yeah, bye. Yeah.
Yeah.
Is there any time duration for lab? Yes, there's a time duration, and I think it's mentioned by the team. Lab will be available till the course or after the course also. Okay, Santosh? Yeah. In this course, can we see the physical switches, also how it work and all instead of the simulation packet tracer? So it's an online session, okay? So we can only see it in the simulation, Manikanta. There is no option as such to see physically, okay?
Shall I leave the classes?
Yeah, yeah, guys. Bye bye. See
Okay,
you
thank
tomorrow.
you. Okay.